All right, folks. Good morning. My name is Karen Lapsley, and I'm excited to moderate this session focused on the highlights of our 25-year journey in nutrition research and outreach at the Almond Board. Today, we'll be focused on heart health with 3 speakers presenting their contributions to the sound science base that has been collectively generated. Our final speaker will be Becky Jeffers from the Almond Board, who will give highlights from our communication and outreach learnings over the past 25 years. So let's get started. As I said, we're very proud of our industry's investment in human nutrition research since 1995. And by 2020, the Almond Board had funded 22 heart health projects with over 40 published papers. You will be hearing presentations on these 3 topics this morning. As well as the research we funded, I wanted to take the opportunity to mention a few other milestones along our journey. The first one being in 2003, when the US FDA granted a nut health claim for the heart health benefits of nuts in terms of showing total cholesterol and LDL cholesterol lowering. That was followed soon after in the 2005 dietary guidelines by almonds being added to the USDA My Pyramid. I know that might not look like a big deal over in the protein category on the far right, but in terms of us being considered part of heart healthy food choices, we were very pleased with that recommendation. At the same time as studying almonds only, almonds have also been incorporated into various eating plans, highlighting here the portfolio eating plan from the University of Toronto researchers that were able to show when you put heart-healthy foods together in a dietary plan, you could get a cumulative cholesterol lowering effect. Then in 2011, it was very encouraging to see that we were accepted to join the American Heart Association Heart Check program for heart-healthy foods. And finally, in 2017, the FDA expanded their perception of heart-healthy foods, and almonds were added to that list. So with that background and context, I'd like to introduce our first speaker today. Dr. Kathy Moussa Velosa is the Senior Director of Health Claims and Clinical Trials at Intertech in Toronto, Canada. She's a recognized expert in the area of health claims and clinical trials. And she has been a guest speaker and participated in various conferences internationally. She's also an adjunct professor with the Department of Nutritional Sciences at the University of Toronto. So without further ado, Kathy, I will pass the speaking role over to you.
Hello, everybody. Today, I'd like to discuss the lipid-lowering effects of almonds. We will start by just having a basic background on meta-analyses and their role in nutrition studies. Then I'll spend some time presenting some results of our systematic review and meta-analysis on the lipid-lowering effects of almonds, which was funded by the Almond Board of California and published in the Journal of Nutritional Science in 2016, and then finish off with some summary points. So clinical nutrition studies are often challenged in that effects are generally small relative to pharmaceutical trials, and they can be highly variable. And compliance can be difficult, especially in long-term studies. And so the number of subjects needed to have robust statistical power is large and often not feasible. A meta-analysis is a way to increase statistical power. Meta-analyses are relied upon by several different scientific and authoritative bodies, such as the Agency for Healthcare Research and Quality, the World Health Organization, and the Dietary Guidelines Advisory Committee, which uses or relies on systematic reviews and meta-analyses as part of their evidence base in establishing policies and guidelines. The Dietary Guidelines Advisory Committee considered meta-analyses as part of the Stage 1 process in preparing the 2015-2020 Dietary Guidelines for Americans. In the scientific report of the 2020 Dietary Guidelines Advisory Committee, the DGAC recommended that meta-analyses be considered for appropriate questions on a continuous basis. The use of meta-analyses in policy and guidelines also is recognized by ARC, which state that the ability to combine small studies with meta-analysis increases the statistical power available to address specific questions. This is particularly useful for systematic reviews of nutrition topics where the availability of large trials is relatively limited or lacking. Finally, in the Handbook for Guideline Development of the WHO, it is indicated that by combining information from all relevant studies, meta-analyses can provide more precise estimates of the effects of an intervention than estimates derived from the individual studies included within a review. So we conducted a systematic review and meta-analysis looking at the effects of almond consumption on lipid lowering. And this work was published in 2016 in the Journal of Nutritional Science. In our research review, we looked at the effects of almonds on several different lipid parameters, including total cholesterol, LDL cholesterol, HDL cholesterol, triglycerides, and the ratios of total to HDL cholesterol and LDL to HDL cholesterol. I'm going to be focusing primarily on the results related to total and LDL cholesterol. So we conducted comprehensive literature searches in May of 2013, and we updated these searches in May of 2014 and again in February of 2015. We searched a total of 8 literature databases using the electronic search tool ProQuest Dialog. And we appraised the quality of the studies using Health Canada's standardized quality appraisal tool for randomized controlled trials. The effects of almonds on blood lipid levels were assessed in a total of 18 publications, which collectively represented 27 different control almond comparisons. To be included in our systematic review and meta-analysis, the study had to be randomized and controlled, and a full-length article published in a peer-reviewed journal. The primary or secondary objective of the study was to assess the effects of almond consumption on blood lipid levels. The study had to report the amount of almonds consumed, and the subjects included in the study had to be adults aged 18 years of age and older. The study duration had to be a minimum of 4 weeks, and fasting blood lipid levels were assessed and were assessed using validated methodologies. So you could see here the forest plot looking at the effects of almond consumption on fasting total cholesterol. In the far left, we have all of the different studies and comparisons. Some studies contributed more comparisons or multiple comparisons. We have the baseline total cholesterol level and how we categorized it. So not optimal, meaning it was elevated, optimal, meaning it was normal. We have here the almond intake per day. So this is recorded in grams per day. For some studies, it was a range. For instance, if it was based on body weight, individual body weight, it was expressed as a range. And then here you see the difference in total cholesterol, the change from baseline caused by almond consumption after correcting for the respective change in the control group. And in this forest plot here, the middle line is the 0 or no change line. And you could see that we are on the left of this line indicating a significant reduction in total cholesterol with almond consumption. So in summary, for total cholesterol, we had 27 comparisons. The pooled reduction was a change of 0.153 millimoles per liter, a change from baseline, that is, and it was statistically significant. And you see a similar forest plot here for LDL cholesterol this time. And again, looking at the forest plot here, we see that we are to the left, and based on 26 comparisons, we have a change in LDL cholesterol of negative 0.124 millimoles per liter. And again, it's statistically significant. We did run some sensitivity analyses in the Journal of Nutritional Science publication. I've got two here that were particularly interesting, and that is that we saw a statistically significantly greater reduction the higher the intake of almonds, both for total cholesterol and LDL cholesterol. And we also saw that the greater the baseline lipid level, the greater the reduction in both total cholesterol and LDL cholesterol. And so, in summary, meta-analyses are used to increase statistical power in studies where effect sizes are small and highly variable. They are relied upon by the likes of AHRQ, the WHO, and the DGAC for establishing policies and guidelines. And in our meta-analysis, published in 2016 in the Journal of Nutritional Science, the consumption of almonds was associated with statistically significant reductions, both in fasting total cholesterol and LDL cholesterol. And the magnitude of the reduction was greater the dose of almonds and the greater the lipid level at baseline. Therefore, the consumption of almonds as part of a healthy diet should be encouraged in order to support the management of blood lipid levels and to reduce the risk of heart disease. Thank you.
Thank you very much, Kathy. Our next speaker is Dr. Claire Berryman. She's an assistant professor in the Department of Nutrition, Food, and Exercise Sciences at Florida State University in Tallahassee. She received her bachelor's and PhD from Penn State University and her dietetic training in Tampa, Florida. Her postdoctoral training was at the Natick Military Nutrition Research Division of the U.S. Army Institute. Dr. Berryman has set up a research program at Florida State, but today she'll be talking to us about the research that she did on almonds at Penn State. Over to you, Claire.
Great, thank you, Karen. Today, my presentation will focus on the results from a study evaluating the effects of almond consumption on traditional lipid measures in addition to emerging cardiovascular and metabolic risk factors. So these are my disclosures. I have received grant and travel funding from the Almond Board of California, which are listed here. The Almond Board of California played no role in the research activities, data analysis, or reporting of research findings. As you just heard, almonds have a well-established cholesterol-lowering effect. Studies consistently show that almond consumption decreases total and LDL cholesterol. Previous research also indicates that despite being an energy-dense food, almonds do not increase body weight, body mass index, or waist circumference. Together, these findings support the heart health benefits of almonds. Previous studies have investigated the effects of almonds by incrementally decreasing some or all foods in the control diet to accommodate the caloric addition of almonds. In the study I will present today, 43 grams of almonds, or about 250 calories per day, were substituted for a calorie-matched high carbohydrate snack to investigate the independent effects of almonds beyond the contributions of a low-fat background diet on both traditional and emerging cardiovascular disease risk factors. The study objectives were to determine the effects of 43 grams of almonds substituted in a low-fat diet for a calorie-matched high-carbohydrate snack. In this case, we used a muffin on cardiometabolic health, specifically lipids and lipoproteins, the biology and function of high-density lipoproteins, which we consider good cholesterol, and then also on body composition. This slide shows the experimental study design. We recruited normal weight, overweight, and obese adults with elevated LDL or what we consider bad cholesterol, a risk factor for cardiovascular disease. After eligibility was determined, baseline measures were collected. Then participants completed both dietary interventions in random order. All foods and beverages were provided to participants throughout each 6-week arm of the study. The background diets were identical and met the criteria for an American Heart Association Step 1 cholesterol lowering diet. The only difference between the diets was the inclusion of 43 grams of almonds or the calorie-matched high carbohydrate snack. And we'll look at nutrient profiles of the diets more closely in the next slide. After completing the first 6-week diet intervention, endpoint measures were collected, then participants had a 2-week washout, and then they began the other diet intervention. And after the second diet intervention is when we collected endpoint measures. This slide provides a sample menu to illustrate the types of foods provided in the diet, and that the only difference between the diets was the isocaloric snack, either the 43 grams of almonds or the banana muffin, and that all other foods in the diet were identical. And this table is showing the nutrient composition of each diet. Differences in the nutrient composition of each diet reflect the contributions of either the almonds or the muffin snack. You can see that protein was similar between diets. However, carbohydrates were lower and total fat higher in the almond diet. The diets were matched for saturated fat content, so the greater total fat content in the almond diet was coming from healthy unsaturated fats, particularly monounsaturated fat that's found in almonds. And then diets were similar in dietary cholesterol content, and the almond diet was slightly higher in fiber. Listed here are the study outcomes we measured, which I will describe in more detail as we move through the study results. And in this table, we have the participant baseline characteristics. Participants were middle-aged and overweight. They had elevated total and LDL cholesterol and had normal blood pressure, HDL cholesterol, triglycerides, glucose, and inflammatory status. This graph shows the effects of each diet on traditional lipid parameters. The red bar represents changes as a result of the almond diet, and the orange bar represents changes as a result of the control diet. On the x-axis is the measured outcome, and on the y-axis is change from baseline in milligrams per deciliter. And different lowercase letters within a variable denote a significant difference between diets. And so our results showed that both diets reduced total cholesterol from baseline, but there were no differences between diets. Both non-HDL cholesterol and LDL cholesterol were reduced more following the almond diet than the control diet. And in addition to reducing LDL cholesterol, low total fat and saturated fat diets also tend to reduce good cholesterol. In this study, we see numerical reductions in HDL cholesterol following each diet. However, HDL cholesterol concentrations were reduced less following the almond diet than the control diet. And due to this beneficial preservation of HDL cholesterol, we wanted to further evaluate the effects of the almond diet compared to the control diet on high-density lipoprotein biology and function. And before I show the results for the HDL-specific analyses, I will briefly cover what each of the measures in the next slide represent. So a consequence of poor cardiovascular health is the buildup of cholesterol in our arteries, shown here in yellow. Cholesterol associated with high-density lipoproteins is considered good cholesterol because it's the cholesterol that has been removed from our artery walls. We call the removal of cholesterol from our artery walls by HDL particles cholesterol efflux, and more efflux is associated with better cardiovascular health. And immature pre-beta HDL particles seen here in this figure accept cholesterol from transporters on the arterial wall. And as cholesterol accumulates, the particle gets bigger and fluffier and more mature. And all high-density lipoprotein particles are considered healthy, but a greater number of the big, fluffy HDL are associated with better cardiovascular health. These big, fluffy HDL particles are called alpha-1 HDL particles. And the HDL particle subtypes are listed on this slide from smallest to largest. And a greater ratio of alpha-1 particles to pre-beta-1 particles is also indicative of better cardiovascular health. This next graph is showing that the almond diet preserved the big, fluffy alpha-1 HDL particles compared to the control diet. There were no differences between diets for the smaller HDL particle subtypes or for cholesterol efflux. We did, however, see that the almond diet prevented a decrease in the alpha-1 pre-beta-1 ratio compared to the control diet, indicating preservation of cardiovascular health related to HDL particle concentrations. And finally, we also measured body mass and composition. This picture is of a dual energy X-ray absorptiometry machine, which does a full body scan to assess fat mass and lean mass. The results of an individual scan are shown on the right. In addition to obtaining whole body assessments, we also assessed regional body composition. The red boxes are highlighting the abdominal and leg regions, which we assessed in the current study. This graph shows there were no differences between diets in terms of total body mass, total fat mass, or total lean mass. However, when we assessed regional body composition, we saw greater reductions in abdominal mass and specifically abdominal fat mass following the almond diet compared to the control diet. We saw a similar result for waist circumference with greater reductions following the almond diet compared to the control diet. And finally, we also saw a greater decrease in leg fat following the almond diet compared to the control diet. So, in conclusion, almonds substituted in a low-fat diet for a calorie-matched muffin reduce LDL cholesterol. Almonds maintain favorable circulating HDL cholesterol concentrations and alpha-1 HDL particle concentrations. Almond consumption has a beneficial impact on regional body composition, decreasing both abdominal and leg fat. And our take-home message today, almonds are a practical and healthy snack that reduce LDL cholesterol levels and improve emerging cardiovascular risk factors, including abdominal adiposity, when substituted for carbohydrate-rich foods within a low-fat diet. And if you're interested in more details about these findings, they are published in the Journal of the American Heart Association and the Journal of Nutrition listed here at the bottom of the slide. And with that, I would like to acknowledge my PhD mentor, Dr. Penny Chris Etherton, distinguished professor at Penn State, who received the funding for this project, and my lab group at both Penn State and my current lab group at Florida State. Thank you.
Thank you very much, Claire. We'll now go on to our third speaker. Dr. Wendy Hall is an associate professor in nutritional sciences within the Department of Nutritional Sciences at King's College London in the UK. She leads the Diet and Cardiometabolic Health Research Group and teaches both at the undergraduate and graduate level. She did her PhD at University of Surrey. She was then at University of Reading for a while, and then she took up her academic appointment at King's College in 2005. So over to you, Wendy.
Thank you, Karen, and the organisers of this session for inviting me to speak about the results from the ATTIS trial. Before I start, I'd like to declare that this research was funded by the Almond Board of California, and they've also funded travel costs to present the research at scientific conferences. but they've not been involved in the collection or interpretation of the data. Snacking habits have been linked to risk of weight gain mediated through diet quality, but also associated behaviours such as lack of physical activity. Therefore, improving the nutritional composition of snacks could be a good way of improving health. In the UK, snacks contribute about 20% of daily energy intake, as shown by the pie chart on the left with the little pink triangle. We analysed the average snack nutritional profile of a large national diet survey of UK adults, the NDNS survey, and we found that saturated fatty acids in snacks contribute 3% of total energy. Here on the chart on the left, you can see the dietary recommendations for saturated fatty acids intake, less than 10% of total energy, with the orange bar showing the average amount consumed above the recommendations. If this 3% of saturated fatty acids in snacks were replaced with unsaturated fatty acids, then the dietary recommendations for saturated fatty acids would be met. Similarly, with free sugars on the right, dietary recommendations are that they should make up less than 5% of our total energy intake, and average intakes exceed that by 7%. We also discovered that sugars in snacks made up 5% of total energy according to this UK dietary survey. So if snack sugars were replaced with an alternative energy source, then it would also go a long way towards meeting dietary recommendations. So I hope I've convinced you that just by changing the nutrient profile of snacks alone, there could be a significant impact on overall diet quality. By swapping snacks high in refined starches and sugars and saturated fatty acids and low in fibre, micronutrients and phytochemicals with nuts such as almonds, this could potentially improve cardiometabolic health. So our research question was, does replacing refined starch snacks with almonds influence cardiometabolic health? And we conducted a randomised controlled dietary intervention study to test this using parallel groups either on whole roasted almonds or control snacks. We measured a range of markers of cardiometabolic health, but we primarily designed the study to detect changes in vascular function and liver fat. The study population comprised men and women aged 30 to 70 years who reported that they regularly consumed at least 2 snack products per day. And we used a cardiometabolic risk scoring system to select subjects at moderate risk of developing disease. Following screening and consent taking, subjects started a run-in period of 2 weeks on the control snacks when they were asked to follow the study intervention instructions. If they successfully completed the run-in period, then they were randomised to the intervention, either almonds or control snacks, for 6 weeks. So to give you an idea how many almonds the participants were asked to consume, an average woman ate a daily amount that would fit on 2.5 post-it notes, as you can see here at the bottom. The control snacks were mini muffins, and on the left you can see a photo of the flavours, the different flavours on a plate. And we provided them so that they could be eaten out of a bag like a typical snack in a variety of sweet and savoury flavours to encourage compliance. Importantly, they were formulated to provide the average nutrient profile of UK snacks using the National Diet Nutrition Survey data. So of the total energy content, 55% was from refined carbohydrate, 14% from saturated fatty acids, and 10% of energy was from protein. We also conducted a 3-week feasibility study, which verified that the control snacks were neutral in their effect on markers like cholesterol, body weight, and blood pressure. So 107 individuals were randomised to the study, and during the study, 2 dropped out, leaving 105 participants who completed the study. Their average age was 57 years old, and there were no differences between groups in the basic screening characteristics, including BMI, with an average BMI of about 27, so generally in the overweight range. Average blood pressure was 125/82, and average cholesterol was 5.6, so in the sort of high normal range. And during the intervention, the body weight remained stable in both groups. So to the results. We found a reduction in LDL cholesterol of about 6% following the almond treatment relative to the control treatment. This confirms previous reports and demonstrates that study participants were complying with the dietary intervention. However, there were no significant differences in liver or pancreatic fat, or body weight, or other lipid measures, or glucose, insulin, or a measure of insulin resistance. Endothelial function was the primary outcome, and we chose this because it's an initiating factor in atherosclerosis and it's predictive of risk of heart disease. So the endothelium is a layer of cells that lines blood vessels, as you can see in the figure in the middle. Endothelial dysfunction can be triggered by a host of different factors, shown here in the box on the right, including a diet high in saturated fat and of high glycemic index, sitting for long periods, diabetes, smoking, pollution, aging, and high blood pressure. So these triggers can lead to an inflammatory response, and the blood vessel then is less able to dilate, and this lack of vasodilation can be measured as an indicator of endothelial function. Dietary factors, such as high intakes of fruits and vegetables, are known to be protective against endothelial dysfunction, possibly also almonds, which is what we're trying to find out, as well as other factors such as physical fitness, being young, and getting enough sleep. They can all be associated with good endothelial function. The gold standard method for measuring endothelial function is by using ultrasound to measure the diameter of the brachial artery in the arm, a technique called flow-mediated dilatation, or FMD for short. FMD measures are predictive of risk of cardiovascular disease. As you can see from the figure, a probe is placed on the brachial artery in the arm, and a blood pressure cuff is inflated to a high pressure for 5 minutes and then released. Upon release, this causes an increase in blood flow through the artery, which triggers something called shear stress, which stimulates the release of vasodilators from the endothelium, leading to artery dilation. Where endothelial dysfunction is occurring, there will be a smaller degree of vasodilation. So the results of the ATTIS trial showed a marked increase in FMD following 6 weeks of almond consumption relative to the control group, as you can see here in the graph, with the green bar showing the response to almonds. So what does this sizable improvement in endothelial function add to current knowledge on diet and heart health? This is the first study to show an improvement in endothelial function following almond consumption using gold standard methodology in a healthy population. However, the results are consistent with similar effects seen previously with walnuts, such as this 8-week trial by Katz and colleagues in 2012. What might the mechanisms be? Both walnuts and almonds contain a range of non-nutrient bioactive components called polyphenols, which might be increasing the availability of a blood vessel dilating molecule called nitric oxide. Also, almonds have a relatively high arginine content, which is needed for nitric oxide synthesis. However, it's unlikely that these factors fully explain these effects, and I think that the most likely explanation is that it is the combined effect of displacing other less healthy snacks that have a detrimental effect on endothelial function and replacing them with a snack that has cardioprotective constituents. In the study, participants were consuming 20% of their energy intake as almonds, roughly about 50 to 80 grams per day. However, average intakes in the general population are very low. Our analysis of the National Diet and Nutrition Survey in an average UK population of 6,802 adults show that only 7% of UK adults consumed whole almonds during a 4-day reporting period. And in these consumers, median intake was roughly equivalent to just 4.5 almonds. So should we be encouraging more snacking on tree nuts like almonds for better heart health? In the UK, the National Health Service advice is to eat nuts in moderation. And while this is true of all foods, it is somewhat out of date, as studies have shown that high nut intakes do not result in weight gain. And actually, we get less energy than previously thought from whole or chopped almonds due to low levels of fat absorption from almonds in the gut. The Eat Lancet Planetary Health Diet emphasises nuts, and the report recommended at least 50 grams of nuts per day. However, almonds are produced in only a few countries. California currently supplies 81% of the world's commercial production. There would need to be an increase in supply from other areas of the world that supply significant quantities already, shown by the smaller yellow spots on the map, in order to start to come anywhere near supplying the global population with significant amounts on a daily basis. More research is needed of how we can encourage consumption of nuts as snacks in the wider global population, taking into account affordability and potential environmental impacts of increasing almond production. So this brings me to the end of my talk, but I'd just like to acknowledge the input of Dr. Sarah Berry, who was joint principal investigator on this project, and also Leanne Smith and Vita Di Carianto, who managed and conducted the study, along with the other co-investigators and contributors to the project. And I'd just like to finish off by saying thank you for listening.
Thank you very much, Wendy. Our next speaker is from the Almond Board. Becky Jeffers is manager of North American marketing. She did join the Almond Board in 2007, and at that time, she was involved in some of our export markets and our export-oriented programs related to China, South Korea, India, and Japan. And she moved over to join the North American marketing team in 2016. So without further ado, Becky, I will pass the baton over to you.
Great. Thank you, Karen. Happy to be here this morning. And with this journey that you've all been witnessing, definitely seen how almonds have come a long way in heart health, nutrition science. And we've had a similar journey along the way in communicating these studies, as Karen alluded to with that timeline at the beginning of the presentation. So I'm going to go a little bit more in depth on that part. But first, I do want to just thank all these nutrition researchers for this great body of science that we're able to see, and also our almond growers who are investing in this important field of nutrition research, because it really is a foundation of our communications and education about almonds. So our journey really began in the late 90s, as Karen was mentioning, with our nutrition research. And really before the 2000s, almonds suffered from this misperception of having cholesterol, right? And contributing to high cholesterol. And the fat was really to be avoided, as in the 90s, it was really avoid fats at all costs. But then by the early 2000s, in our consumer research, we were showing that a majority of consumers believe almonds were good or even excellent for being heart healthy, with 70% responding there. And next slide. And from this foundation of heart health research, we've really been able to evolve our meaning in the context of health. So really leveraging the lowering cholesterol studies that we were able to establish in the late 90s and early 2000s, we were able to build and keep building. And one of the great things we've been able to find throughout these studies is the weight management aspect of almonds as well. And so our handy portion control tin, or a serving size of almonds, one serving equals 23 almonds or an ounce, was developed to help communicate through a weight management study, but it also helps to communicate very visually what a serving size is. Then go ahead. We then, as Karen alluded to, been able to say that almonds are actually healthy, with the FDA allowing that language based on an increased understanding of fats. And we're able to leverage that language and be part of the world's healthiest foods. And then next, we're also now moving into what we consider as a lifestyle nut, and being part of people's overall definition of what healthy means and living a healthy lifestyle. So go ahead and click. With this growing trajectory of health benefits and how we've been able to evolve that meaning of almonds and health, we've also been able to see category expansion. And, compared to 2006, when it was mostly an ingredient, now these days we see a variety of categories, including almonds, and really benefiting from this expansion into lifestyle, what everybody wants to seek in a healthy lifestyle. Next slide. And that's a good thing, because today's world is really complex, with a lot of different folks looking for health in a variety of ways, all these types of eating plans and dietary needs. So almonds fit into all of these, which is wonderful news. And we're excited to be able to talk about almonds in a variety of ways to fit people and meet them where they're at in their health journey. Next slide. And in fact, in some surveys, this was done by IFIC, and 1 in 4 consumers actively seek foods for health benefits. You can see that heart health rises quite high to the top of those who are actively seeking health from their food. But there's a lot of things people are looking for from their food. And so it's really important to communicate about food for those people who are really needing and wanting these benefits. And it's interesting because, sorry.
Sorry,
Karen.
Sorry,
That's okay.
okay.
It's okay. It's just interesting because I was going to say there's a little asterisk. It's a sidebar, not really related to heart health, but new in 2020 was improved sleep. So folks can kind of see where priorities are changing for folks, probably due to the events of this year. And also compared to the 2019 study, immune function has risen on this list. So it is interesting to see the health trends, but also just holistically understanding consumers really want their food to work for them, right? All right. Go ahead. And in the US and globally, we've surveyed consumers ourselves, and we found that almonds are really strongly associated with heart health. In fact, it's the #1 response when we ask, what is the nut best for heart health? It's almonds. So we really see that our investment and our continuation of education in this field has resonated with consumers, and they really link almonds and heart health. Then comes weight management and then energy. And we can see these results across other countries as well. It's actually the exact same order. They give credit to almonds for being heart healthy, and then for weight management and energy across Canada, Mexico, China, India, and South Korea. Go ahead. But we know consumer attention is short these days. It's similar to a goldfish, so I probably lost you already. Just kidding. Go ahead, Karen. And to get through and kind of cut through in this cluttered media environment, we pursue 4 key elements. And one is transparent science, which we've demonstrated today as a sample with our heart health research. And we continue to pursue that in all of our scientific understanding and nutrition studies. We also want to understand how almonds fit in people's lives. So those consumer surveys we do to be relevant to how they're eating, what they're thinking about health. And then lastly, getting the support from healthcare professionals as experts. So again, thank you to our partners of the registered dietitians, and also our nutrition researchers who contribute to this process. Go ahead, next slide. Into putting it into practice, we've captured a couple items here, like seeing almonds in the news here on WebMD. One of the very first paragraphs in this article was all about almonds' heart health benefits. So even though our journey has taken us even beyond heart health, our foundation really is in understanding that heart health benefit. And so it's always good to see that captured to the public. We also leverage this in our advertising, as you can see in the middle. And then Karen referred to our American Heart Association partnership, and you can see that on a variety of whole natural almond products. Next. We also have a plethora of resources on our website, almonds.com. We have a section dedicated to dietitian tools with handouts that can be used for your clients or also for your own benefit. And then we have really easy consumer-facing messaging throughout as we talk about the nutrition benefits of almonds. Hold that attention span a little bit, maybe. And that is what I wanted to share with you today. But again, just a big thank you. And we're excited to always continue pursuing our communication and education about almond heart health benefits.
And I'm now going to pass over to my colleague, Dr. Kalgankar, who I think has a couple of questions for each of our speakers.
Thank you, Karen. I'd like to take a quick moment to thank all of our speakers for their wonderful presentations. These presentations, as our viewers can tell, presented great research from robust studies, which have actually been published in high-impact peer-reviewed journals. So thank you all for that. And without further ado, we'll get into the question and answer session. So Wendy, we'll go ahead and start out with you. And our first question to you is, why is it important to look at endothelial function when it comes to heart health?
Well, endothelial function is really important because it tells us a lot about the vascular health of individuals who do not have diagnosed heart disease. And therefore, we also know from large observational studies that FMD is predictive of risk of heart disease. And so we can use an improvement in FMD following a dietary intervention to predict that there will be a protective effect if this was sustained. So FMD is not a standard clinical measure like blood pressure or cholesterol, but endothelial dysfunction is involved in the early stages of atherosclerosis development. So it can be really useful for looking at the beneficial effects of dietary interventions alongside standard clinical measures.
Okay, well, thank you very much. That's very useful information. With that, we'll have a question going to Claire. Claire, your question is, please tell us a little bit more about the role of HDL and how the different HDL subparticles are important to look at, and also why it was important to look at it in depth in this particular study.
Sure, thank you. And so I'll start by saying that it's very typical to see a reduction when we see low-fat diets administered. We typically see this decrease in LDL cholesterol or the bad cholesterol, but we also see a decrease in HDL cholesterol or good cholesterol. So there's been a lot of research establishing that consumption of almonds can decrease LDL cholesterol. Kind of the next step was to look at whether almonds are able to preserve HDL, both total concentrations, but also particle size, and improve cholesterol efflux. So it was kind of the next research step to take. And we know that HDL cholesterol is very complex, and we used to look at just total cholesterol and then broke that down into LDL cholesterol and HDL cholesterol. And now, as we're learning more about HDL cholesterol and its functions, we're moving beyond just measuring total concentrations to also measure particle size and its function, and also its ability to prevent inflammation. And there's a lot of emerging research on the role of HDL in cardiovascular health. So just kind of taking the research that one step further and looking at how almonds can impact HDL cholesterol.
Thank you for that. I should say the image that you provided for LDL, creating a mess with all the fat cells in the endothelium, and then HDL actually carrying that away. That is a very impactful image, definitely is worth 1,000 words. So thank you for that answer. The next question goes to Dr. Moussa Velosa. Kathy, one of the inclusion criteria for studies during your literature search was including studies with a duration of equal to or more than 4 weeks. Why is this minimum duration important? And is the heart health benefit greater and better with longer study durations?
Thank you, Swati, for the question. That's a really good and an important question. First off, to start with our criteria for study inclusion, we did require that the studies be at least 4 weeks. And this is so that we could establish a steady state and truly understand and ensure that study duration was not a factor in why perhaps we wouldn't see an effect. So we came across studies that were just, for example, a week in duration, and a week may not be enough to see an effect on lipid levels. So we thought 4 weeks would be a minimum and a good amount of time to at least allow for an effect on blood lipids if there is an effect. Now, with respect to the question as to did we see better effects in longer term studies versus shorter term studies, so we did do a sensitivity analysis in our 2016 publication in the Journal of Nutritional Science, where we used 12 weeks as sort of the cutoff, and we looked to see whether effects in studies shorter than 12 weeks were any different than effects in studies longer than 12 weeks. And unfortunately, we saw reductions either way. We didn't reach significance with studies longer than 12 weeks. But I think it's because we only had 6 comparisons in that category compared to 21 in studies that were 12 weeks or shorter. So I think it just became an issue of just not enough, again, statistical power to see an effect of longer term studies. The other point to consider too is that it could be difficult for subjects in clinical studies to have to consume their amount of almonds every day for a prolonged period of time. So we could get into issues of compliance with longer term studies, which is of course something we can't rule out entirely. So it begs the question of whether different types of almond products might be important to include in these studies as opposed to just one type. So maybe having roasted almonds, raw almonds, different flavored almonds. I wonder if that could be one of the strategies for really long-term studies to try to keep compliance high and investigational products interesting.
That's a very good point, Kathy. Thank you for that answer. Our next question is for Dr. Hall again. Wendy, you see, and we all know that control foods are used as part of any intervention trial when we're talking about whole food trials. So please tell us a little bit about why a control food is important in a study like this. And also then please tell us more about the control muffin that was developed as part of your study and how it might compare to a commercial counterpart.
Okay, thank you. So it's really important to think about the design of your control when you're designing a dietary intervention study as a randomized control trial. The choice of control can be really difficult with dietary intervention studies because quite often you're trying to control for quite a few different factors, but it needs to be acceptable to the volunteers as well, that they're going to stick with it, that it's going to be palatable. And so the choice of control is crucial for drawing meaningful conclusions from any study. If the control food changes the outcomes you're looking at, then any differences between treatments might not be due to the beneficial effects of the treatment, but instead due to a worsening effect of the control. Or you could mask real effects of the treatment if the control food happens to improve outcomes as well. So this is why we wanted to make sure that our control muffin followed the average nutrient profile of snacks in the UK, according to the large survey I mentioned, so that we could supply a standardized snack, and we would know what the participants were consuming, but we'd also know that it'd be neutral and it would have no effects on the cardiometabolic risk markers. And so that's why we conducted the feasibility study. We expected it to have no effect on cholesterol and blood pressure and body weight. And in fact, that was what we showed. And we were also able to collect data on acceptability as well. So the people who in the feasibility study gave us scores on how tasty they were and things like that. So that was all good. But comparing them to commercial muffins is a bit difficult, as commercial muffins vary depending on the manufacturer in their composition. But I think probably because our muffins reflected all snacks on average as they contribute to the average diet, they were probably lower in saturated fatty acids than muffins you might buy in a supermarket, and a bit higher in total fat as a portion of energy. Also, they didn't come in one big muffin like you often buy them in the shops. They were mini muffins so that subjects could eat them out of a bag like a snack. And they came in lots of different flavors, sweet and savory, so the participants could have some variety rather than having the same thing every day.
Thank you, Wendy. That's really great insight into all the work that goes into making sure a control food is actually appropriate for this study. So thank you very much for that. We do have another question for Dr. Berryman. So Claire, you know how with every new year, we all make new resolutions, and somehow the resolution to reduce waist circumference and waistlines happens to get renewed every year. And none of us really think about how important that might be for our heart health. Of course, we want to look good and feel good. And I think most of us make the resolution out of that need rather than really thinking about heart health. So could you tell us a little bit about why or how an improvement in waist circumference might be related to improved heart health?
Sure. Thank you for that question. So the main reason is that it matters where fat gets deposited in our bodies. So we know that fat deposited in the abdominal region is more metabolically active and thus more dangerous or has a stronger association with cardiovascular risk factors and cardiovascular disease. So either decreasing the amount of fat deposited in the abdominal region or redistributing it to other regions, such as the gluteal region, has protective effects on cardiovascular risk. And so we use waist circumference kind of as a surrogate marker. It doesn't directly measure fat in the abdominal region, but many people don't have the resources to measure abdominal fat using DEXA like we did in this study, or using MRI or some other techniques. So waist circumference measured with a tape measure is an easy way to assess how your waistline is changing. And that's a good indicator or has a strong association with the amount of fat that's deposited in the abdominal region. So yes, so that's a very beneficial resolution to continue to try and decrease fat in the abdominal region.
There is another reason besides looking good to try to reduce that waistline. Thank you, Claire. Well, our question and answer session would be incomplete without a question for Dr. Lapsley. She has searched the almond industry for a little over 20 years and is definitely an expert in all things nutrition research for almonds. So with that, Dr. Lapsley, please do tell us a little bit about how far you feel the almond heart health research has come from when it first started, and how do you see it evolve going forward?
Whoa, okay. All right. Well, back in the 1990s, there was a little bit of a low fat, no fat craze. So from that perspective, almonds were definitely not included in terms of being a healthy food and a healthy snack. So when I joined the almond board, we only had two studies that had been published, 2 preliminary studies that had been published, and they were very small. So from that perspective, it was clear, and I think a range of experts gave us, including Claire's PhD advisor, a range of experts gave us advice that the almond industry would have to invest significantly in nutrition research to show these benefits. So in terms of heart health, we obviously did start funding studies in North America, both in Canada and the US. Then we expanded to Europe and have done some work in Asia as well, because that was another question. What does the culture and ethnic background of a diet and of a population, how does that play into food choices? So we also went down that path too. And I think the likes of Dr. Moussa Velosa's meta-analysis are the types of overview studies that need to be done to look at the totality of science. So we are obviously very proud of the 20 plus years of investment and the positive results in this area. And lo and behold, when FDA, without our involvement at all, but when FDA in 2017 realized and made clear that foods that have a significant fat content but have healthy fats can play a role as healthy snacks and healthy diets, I think that was a big inroad for us. But as well, as you've heard today, the research field has gotten more complicated. Flow-mediated dilation, for example, who knew that that was going to play a role overall? And as you just asked Claire about, who knew in terms of waist circumference that even something like that can, where the fat's deposited in our body, can play a role. So yes, it's been a very rewarding journey, and a whole army of researchers and health professionals have helped us do the research and get the message out. So from that point of view, I thank everyone that has been involved in this journey with us.
Thank you, Dr. Lapsley. That was a very, very nice, succinct, and rounded answer. So thank you very much. With that, I'd like to thank all of our speakers and for everyone who helped make this session a wonderful session. So thank you very much and have a wonderful day.